Hello everyone. So in this video onwards we will introduce you to computer vision, and starting from this video there will be a series of small videos on computer vision which would help us to explore the OpenCV library, and finally after some more understanding it would finally lead us to understanding of convolutional neural networks. So let us just start with today's video topic, introduction to computer vision. So they are basically computer vision are basically computational methods for analyzing and understanding digital images. So let us first understand that an image is basically made of pixels. You all know that, right? And the pixel values is an integer which ranges from 0 to 255. So if we are talking about a grayscale image, so what does a grayscale image means? It basically has only black and white. So if we have a margin of 0 to 255, 0 means a complete black pixel, and somewhere in between 0 to 255 it would mean that we are having some degree of grayness in our pixel, and and if we set our pixel value to integer of 255, we have a complete white pixel. So that is the basic understanding of a grayscale image and the values of pixels. So if we have a grayscale image, it is basically a 2D matrix. So we have a 2D matrix in which each element of the matrix is an integer lying from 0 to 255, and and if we have an RGB value, which we have 3 color channels for that, in that case it will be a 3D matrix. So for a colored image, so let's say we are having this pixel, and we have 3 scales of 0 to 255. One scale, if it is complete 255, it means, and other 2 scales are 0, it means that we have a complete red image. And this, so one this R value of 0 to 255 tells us that how much our image lies between black and red. So if it is 255 means our image is completely red, and given that the other values are also 0, so our degree of green or degree of red, if we can increase or decrease, so by increasing these all of these bars, we can get all sorts of colors. So yeah, a colored image is basically a 3D numpy array, and the front we have it is always of the format of m cross n cross 3, where 3 is the R, G and B channels, red, green and blue channels. These are the 3 primary colors which makes up all of the colors, as you would be knowing that. And so as I told you, gray images are basically 2D matrix of numbers and colored images are 3D matrices. So OpenCV is a library in Python which makes our work of image processing in computer vision easier. So computer vision is mostly about image processing, how to process an image intelligently. So first we will pip install this OpenCV Python. No, so as I told you, a complete black image would consist all of its pixel to be 0, right? So we import this CV2 image library at CV, and we import numpy as np, and we also import math. We create a matrix using np.full function. It helps us to create a 600 cross 600 matrix whose each of the element is 0. So we create a matrix such that it is completely such that if we try to view that matrix in terms of an image, it would appear as completely black. Then cv.named window helps us to name the window as image. You can see that this window whose output is shown, the name of the window is image, and it is a normal window. There are also possibilities of other windows which you can explore. We also have cv.imshow, which helps us to show an image. So we take this matrix and we say that each of the matrix should be considered as an 8-bit unsigned integer, and we just reference that as a type in image show, and we say that this particular image only we want to show now using cv. And this wait key, so what does this wait key actually do? It takes it in argument, it takes the number of milliseconds. So if I put 5000, it means that this window will be open for 5 seconds. So if I put 0, then it means that the window will be open for as much time as we want till any of our key is pressed. As long as none of our key is pressed, we will have this output window. As soon as we click any of our key from the keyboard, this window will vanish and our program will be terminated. So as soon as we click any of, I have put 0 here for that purpose. So as soon as I click any of the key, the execution of the program will move to the next line, and cv.destroy all windows means that this window would be destroyed and our program will, and our this block of the program termination would come to an end. So that's how a normal framework of OpenCV image showing, image loading actually works. So I will show you image loading. So again we import cv2 as cv, so we can read an image from that. So from cv.samples we can find file like this. So we will basically use a link to the our image. I have this image in my desktop. It is an animated cartoon character. So if image is none, you can just exit, could not read the image. If there is some issue with the image, then we could not read the image and the user will be displayed that. And cv.imshow is used to show an image, as I told you, display windows, which is img. Now k, I put it as cv.wait key of 0, and wait key of 0 means till any key is pressed. So what exactly happens here is that when cv.wait key of 0 waits for a certain key to be pressed, as soon as we press that key, it returns a value. That value is stored in this variable k, and in this statement I say that if k is equals to odd of s, it means that is if I press s from the keyboard, so that particular value will be equal to k. So if wait key senses the s from the keyboard, so if s is pressed from the keyboard, then we need to save this image in a file. So let's say we then to save the image we use cv.imwrite. So let's say we give any random name to an image .png, and we use this img variable, and then we use destroy all windows. So yeah, if we click s, then all the windows will be destroyed, as well as our program will also be terminated, and as well as we would have this image saved in a file. So there is a requirement of saving an image. As you know, we might do some manipulations with this image, and then we may be requiring to save this final image, right? So for that purpose we use cv.imwrite, and we can choose exactly which key to press so that our image will be saved in this manner. I hope it all makes sense to you. So we can also read an image in grayscale format. So in just in the second argument, I need to mention cv.imread grayscale. So in our previous, I didn't mention, I am directly using cv.samples.find file, so that I don't have to mention any second arguments. Otherwise the use of second arguments inside cv.imread is mandatory. If I want to read a grayscale image, I can just write cv.imread grayscale, or if I just write 1, then we will get a colored image. And cv.named window, we have a named window again. As I told you, it is a normal window. We do cv.imshow, we say that it is an unsigned integer. Each of our pixel values of image is an unsigned integer. We give cv.wait key of 0, and then destroy all windows. We also see that the shape of the image is of a 306 cross 474. So that is the number of rows and columns of our matrix image. So we can also manually convert an image into a grayscale image. So how we can do that? This is the function. This is the function which we are using to directly load a grayscale image. So we can convert our values to also a grayscale image. So how can we do that? So first we select the RGB values in our image. So this colon means select all the rows and all the columns and the last channel. So one thing you must know, that in OpenCV things are stored in BGR format. So we need to just interchange all that. See, this is BGR format. So it was the last value was R, That is why the first value here is 2, which is R. So I saved all the values of the pixel in RGB channels. So I extract out the channels in this way basically, and then using gray I am just creating a image which is completely white, which is also the shape of the image, same shape, and I am just traversing through our image. It is after all a 3D matrix, right? It is a 2D matrix as of now. So I am just traversing through our matrix, and in the gray, which is the complete white image which I created, I just put an average value of R, G and B. So from the RGB channels we extract it in the same way, and we just average out all the RGB values to obtain a grayscale image. So cv.named window, again the same things we would do, destroy wait key and destroy all windows. So in this way we can also do image manipulation pixel by pixel. So you can also imagine few things. If we can traverse through each of the pixel, we have a lot of control of our image, right? We can do a lot of interesting stuff now. We can basically do a matrix transpose, and then the image will be flipped. Yeah, and we can also rotate the image. So we can do many other things using by as we know that image is basically a numpy 3D numpy array. So we will see more of such fun stuffs in some of our next videos. So next few videos will be of short duration, which would just say which would just give a lot of idea about the OpenCV module, what more manipulations we can do on our images. So yeah, that's all from this video. Thanks for watching it till the end.